Welcome to MIG Monday. I'm Paul. This is Justin. He's with Xiris Automation. They're the people that have provided the cameras for these great weld shots that you've seen and will be seeing during the course of this program. One of the things I'm really happy about is to be able to show you this, some of these weld shots, because we talk about weld placement and what happens in the puddle, and with these really great videos that these cameras can provide, it's pretty easy to see what's going on. Now, in the video we're watching right now, it's a fillet weld, and one of the beauties of this thing is you can see where the wire placement should be in that joint. You get to see the puddle the molten puddle following along behind the weld, and whether it's tying in, you got equal leg length on both plate. There's a zillion things you can kind of pick up on by seeing a video like this. One of the other things I like about it is because we've talked about what the short arc process is, and they call it short arc because you have a wire and your work, and you've got an arc between there. But what happens when the wire touches the molten puddle? It shorts out, and hence the name short arc. Okay, the arc goes out, but because there's so much resistance there, and you still have current flowing, the wire heats up almost instantaneously and explodes. That's where the spatter comes from, and recreates the arc. And this happens over and over again, up to somewhere around 200 times a second that can happen in this short arc process. And by watching this video, you can kind of get an idea that that's how it happens. So that's just one of the things that impresses me about the ability of these cameras and what they can do. But Justin, if you could take a little bit of time and maybe explain to some of the people about what the cameras do, some of the applications and things like that, I think they might be very interested.
Absolutely. So what we have is a high dynamic range camera, which means it can resolve extremely bright levels of light without saturating. So you can look at a live arc process while seeing right at the arc, the puddle, and the background all in the same image. And we accomplish that without filters. We use a really special sensor that has a logarithmic output, so the voltage to light ratio coming off the sensor doesn't ever peak. You never bloom, you never saturate, and you always have an automatically beautiful image.
That's pretty cool. What are some of the welding processes, or maybe some of the experiences you've had in using these cameras for some of the welding processes around, or the applications that they would have?
So all kinds of different applications apply to our camera. We go everywhere from educational facilities, where we're putting these cameras in schools, and instructors are recording their welds, and they're displaying them to students on large screen TVs in the classroom. That way they don't have to have 10, 15 students all trying to look over an instructor's shoulder.
Oh, that's pretty cool.
So at the same time, those instructors can then have their students record their welds and go back and look them over afterwards and see exactly where they've gone wrong. And you don't have to have one instructor trying to run between 15 booths, trying to help out every student individually at the same time.
Wow, that's pretty slick.
Yeah, so
I think instructors would kind of get a big benefit from that.
Yeah,
sure.
we give the instructors a break. We try and help them out, and the students like it too. A lot of them actually request to take the videos home at the end of the day. They can review their own welds. They can show their friends what they're doing in school. It's a really neat tool, as well as something that's very useful.
Pretty cool.
Here's a perfect example of how our camera is being used for educational purposes.
Yeah, this is one we did in an earlier episode showing the differences in stick out, how the stick out affects the weld.
Right, so you're able to record welds with limited variables and show students or interested parties exactly what's happening when a single change is made to a process.
Yeah, that's really slick.
So the second main application of our camera would be in labs. We go around a lot and show this off in the really high-end, state-of-the-art laboratories where they're developing these weld processes. And because you can see it in such high detail, they're able to cut down on their research time. They're able to take away guesswork.
Well, that's an advantage for sure.
So we take our camera into these labs, and it's got flexible optics. So if you want to be looking at a 2mm field of view and watching your wire feed, or if you want to be looking at your overall process, these optics can be swapped in and out and adjusted so that one camera can be used for anything.
Oh, so you can use it for like an extreme close-up or even a wider view?
Absolutely, and it can be changed out in a few minutes.
Wow.
Here's a great example of our camera being used in process development. The camera was able to capture a laser weld and identify an issue that the engineers couldn't see from visual inspection. We're able to zoom in to a really high detail and play back at an extremely high frame rate. So in this instance, we windowed the camera down and ran at almost 200 frames per second and stepped through frame by frame to identify exactly where the issue took place.
Wow.
So at the bottom section of the weld, when the laser starts, it's actually off alignment. It's starting too high up and missing the seam. But by the time the laser gets all the way around, it's now covering the seam. So a visual inspection appears to have the weld bead on point, when in reality, it's way off. Xiris also offers a color camera now. And here we're looking at a titanium TIG process.
You know, I can see where color would be important in the filming of something like this, because when you're welding titanium, you don't want to have a big heat affected zone, and as it gets hotter and hotter, there's color changes. So by having a color camera, you can kind of you can see how much heat input you have in there and help control the process so you don't weaken the base metal. That's pretty important.
So the third major application for our camera is industry. So we have semi-automated and automated processes, and that's where we have the industrial version of the camera. So this is the same electronics, same image, all inside an industrial packed body. And this is mounted on gantries.
Oh, so that's basically more like a more solid or protected
Exactly.
camera.
And it's got more features built in too.
Ah.
So we've got a motorized focus inside, we've got built-in lights, we've got a removable spatter guard. And all this is to help the camera stay alive in these really dirty environments where we don't want the welders.
Yeah. All right, Justin, you said that you have a series of applications where this camera can come in very handy. I'd like to see some examples of that if you could.
Absolutely. Here's a manufacturing example where cameras are being placed inside a closed automation cell. And the welders aren't able to go in and watch the weld. So parts aren't inspected until 24 of them are made and brought out the other end. So when a defect forms or something goes wrong with the process, you've got 24 pieces of scrap now. So when they are able to watch it live and they're able to see the background, the weld tip, you're able to put a stop to the process before a big problem happens.
Oh, kind of minimize the scrap, and you do company savings with that.
Absolutely. And because we can see the background, we're also looking at the rollers. Mm-hmm. These are things other cameras can't do. They have a problem looking at the weld and the background at the same time.
Oh yeah, like a weld spatter or something got on a roller to take the part out of the proper orientation.
Exactly. So this is Weld Revolution's spin arc process.
Spin arc? You mean the arc is twirling around? I mean, it looks in the video, it looks like there's like maybe 2-3 wires there. Is that accurate?
Right, so what we can do, because we're running at 55 frames a second at a really high resolution, we can slow it down and go frame by frame. And you actually see that it's a single wire spinning at about 3,000 RPM. This is a great example of where Weld Revolution was able to use our camera to show their potential customers how the spin arc process worked.
Wow.
So here's an example in a manufacturing environment where the camera is being used to remove the welder from a dangerous and small area, and they're controlling the side-to-side movement and alignment from about 40 meters away.
Wow.
So we're in about a 3-inch deep groove joint.
That's pretty slick. You know, in a lot of applications in manufacturing, especially when you're doing critical welds, like nuclear, you know, having a documented view of the weld, which can be extremely beneficial if not mandatory.
So we're taking the welders away from the process so they can be comfortable while they control their processes. You know, if you're welding 15 feet in the air, you don't want your operator sitting up on a ladder. Now you can have him on the ground watching a screen, right?
Yeah.
It just makes sense.
Well, I can certainly see how that can be a big advantage for a welder to be able to control his arc and everything from a distance. It gets you see a better view because of the camera, and it's certainly in a bit safer work environment as well. So I think that's a pretty important deal. Justin, you have anything you'd like to add to that?
Sure. If you're looking for more information or you want to see some interesting videos, come check out our website. We've got an extensive video library you can look at, all kinds of different processes.
Awesome. Okay. Well, I guess that would conclude this episode of MIG Monday. I hope you guys enjoyed that, especially seeing a lot of different welding processes that you normally wouldn't see on this show, and some nice, really cool close-up videos of the arc. So Justin, I really thank you for allowing us to use your camera, and thanks for coming.
Thank you.
Okay, guys, that's it for MIG Monday. We'll see you next time. Well, if you learned something today or like what you saw, please feel free to subscribe and keep an eye out for new episodes every MIG Monday.